Welcome to another Function Transformations 3 Steps to Sketch. And in this video, we are going to be looking at the transformation of the square of the reciprocal function. So we'll graph y equals negative 1 over x plus 3 squared minus 2. And we'll do this using our table method. All right, here's our equation and our outline. And before we start step 1, where we analyze our transformations, let's remind ourselves what this parent graph looks like. So the parent graph is y equals 1 over x squared. And this is the one we nicknamed volcano. It has curves. It's not a very good sketch. It has curves in the first and second quadrants. All right. So now let's analyze our transformations. And we can see that this x plus 3, that is going to tell us what our horizontal transformation is. Okay, the transformation is in with the x, so denoted by the parentheses. Okay, we know that this will impact only the x coordinates, and we should consider this one using a helper equation where we set the transformation equal to 0, and that'll help us discern what kind of transformation is going on here. So to solve our helper equation, you would just subtract 3 from both sides. And so that's the transformation that's happening here. We are subtracting 3 from our x's, which moves our graph left 3. So it's x's minus 3. And that's our only horizontal transformation. So now we can move to our vertical transformation. Those are going to affect the y coordinates only. And we can see that that's this negative out front, that's like a negative 1, and the minus 2. Okay, when you have multiple vertical transformations, apply them in PEMDAS order. So the multiplication, or in this case the reflection, comes first, and then the shift, the move down 2, comes next. All right, so if it is a vertical reflection, that means we're flipping over the x-axis. So we'll write reflection over the x-axis, or just multiplying all our y's times negative 1. Or even more simply, just changing the sign of all the y's. Okay, then we will move everything down 2, or just subtract 2 from our y's. All right, so now that we know what kind of transformations we're working with, we can move on to step 2. Create a table starting with the parent points, and then apply those transformations. So referencing our sketch at the top, we know that our points are 1, 1, and negative 1, 1 from our parent function. We also know that we have both a vertical and a horizontal asymptote. We won't sketch those in quite yet. We'll only do that for the final so our graph stays cleaner. But it's nice to see, okay, that's what's going on. We will talk about how you can just look at the equation to see where your asymptotes should fall for your graph. All right, so we only need those 2 points. Let's go ahead and transform. Okay, our x's, we know we are moving them left 3 or subtracting 3. So 1 minus 3 and negative 1 minus 3. Okay, and then we have our 2 vertical transformations. We change the sign of our y's, and then we'll move down 2. So change the sign on those y's and move them down 2, easy enough. Okay, so we know our final points come from our outermost columns. That's here and here. And let's go ahead and plot those. We have negative 2, negative 3, and we have negative 4, negative 3. All right. So before we sketch, it's helpful to know where our asymptotes should fall. So remember our first asymptote, let's start with x equals 0, or our vertical asymptote. That's an x equals 0. So it's only going to be impacted by moving or shifting left or right. If you try to move a vertical line up or down, it doesn't really change the result. Okay, so if you move that vertical line left 3 units, you can see it actually ends up falling nicely between our final points that we have plotted. Okay, exactly halfway between. So our final asymptote is at x equals -3. All right, then let's think about our horizontal asymptote. The original one was at y equals 0. So reflecting that doesn't really do anything because it's on the x-axis, so a reflection won't change that. But the vertical shift, in this case moving down 2, does affect it. So you have a horizontal line, you can move it up or down. But note, moving it left or right would not change its actual position. All right, so move that line from y equals 0 to y equals -2. We just shifted it down 2. And that should really help you see how to draw in or sketch in your final graph. One final other thing to note, you should be able to just look at the original graph and remember that you reflected vertically, you flipped it over the x-axis, and so now it should look kind of like an upside down volcano. So sketching that in, and there you have it. One other thing to note, check out that original equation, and you can see from the x plus 3, if you just set that equal to 0, you would actually solve and find that the vertical asymptote should be at x equals -3. And then this -2, this vertical shift, shows in the equation very clearly. So you could easily just glance at the equation and see that your horizontal asymptote should be at y equals -2. So just a nice little extra note to make. Other information you can gather right at the beginning. All right, so that's our graph of this square of the reciprocal using the table method.